Hi there, I'm Holly Carr with the U.S. Department of Energy, and I'd like to welcome you to the January edition of the Better Buildings webinar series. In this series, we profile the best practices of Better Buildings Challenge and Alliance partners and other organizations working to improve energy efficiency in buildings. And today we'll be taking a look down the road a bit at up-and-coming technologies that could become key arrows in the building energy efficiency quiver. We'll hear first from our very own Andy Mitchell at DOE, who will describe our HIT Catalyst program, that stands for High Impact Technologies. And we'll be talking about how DOE scours the globe to find market-ready technologies with the most promise for big energy savings in U.S. buildings. Andy will describe our program to demonstrate these technologies in real buildings with real people as an on-ramp to increase adoption. Next, we'll hear about two of this year's HIT Catalyst technology demonstration projects. We'll speak with Roberto Nunez from host site New York Presbyterian Hospital, and also with Udi Meyrev from enVerid. We will regale you with a description of the technologies in the demos and hopefully some early results. And then finally, we'll let you know of existing and upcoming opportunities to demonstrate exciting new technologies with DOE in your buildings. So without further ado, let's move up, I think, maybe 2 slides. Let's see what we have. There you go. That's what's happening. And here are our presenters. So let me introduce our presenters in a little bit more detail. Andrew Mitchell is a fellow supporting the U.S. Department of Energy's Better Buildings Alliance. In this role, Andrew manages the technical solutions teams by balancing input from Alliance members and from the private sector, as well as industry experts and our national labs. Andrew has held positions at General Electric, AEP Energy, and Enernoc before coming to us at DOE. Next, Roberto Nunez. Roberto is the Director of Facilities Operations and Engineering at the Allen Hospital and the Spine Hospital for New York Presbyterian Hospital in New York. Roberto has been working with New York Presbyterian for 12 years and has 17 years of experience working with direct digital controls. Finally, Dr. Udi Meyrev is the founder and chief executive officer of Boston-based enVerid Systems, which has developed and commercialized groundbreaking HVAC load reduction technology, a modular intelligent scrubber system for indoor air that enables dramatic reductions in HVAC energy consumption in commercial buildings. Before enVerid, he served as CEO of Boston-based Luminous Devices, an independent developer of high-performance LEDs for solid-state lighting applications. Udi also has a PhD in physics from MIT, and his early career started out as a semiconductor research scientist. So thanks to all 3 of you for joining us on the webinar today to talk about these new technologies and the demonstration work that you're doing with DOE. Before we get started with our speakers, I want to remind our audience that we will hold questions until near the end of our session. Please do send in questions that you have throughout the presentations through that chat box window on your webinar screen. We'll be collecting those throughout the session, and we'll certainly try to get to as many of them as we possibly can. Also, this session will be archived and posted to the Better Buildings Solutions Center website for your reference. Let's see, to start us off, let's go ahead and get the download from Andy on how DOE's Building Technology Demonstration and Deployment Program works, and an overview of this year's highlighted technologies. Andy.
All right, thanks a lot, Holly. So my role here is to fill in and sort of explain how the DOE decides what cutting-edge building technologies to focus on and what we do once we have identified them. Take me to the next slide, please. So we call these cutting-edge technologies high-impact technologies, or HITs, which is kind of a catchy name. In the world of energy efficiency, it's tough to come up with these sort of inspiring titles, but the HIT list is one of them. So the high-impact technologies are cost-effective, underutilized, energy-efficient commercial building technologies. Through the HIT Catalyst program, which was initiated in 2014, DOE identifies and guides HITs through their early market introduction phases, ultimately leading them to broader market through partnerships with commercial buildings industry. That's via Better Buildings Alliance, federal leaders, regional nonprofits, utilities, and efficiency organizations. HIT Catalyst also serves as the umbrella program under which all of the commercial buildings integration programs technology-specific deployment activities fall. And that is along with the Tech to Market initiative at DOE, very similar, which plays an important role in many HIT Catalyst market transformation activities. We'll go to the next slide here, and I'm going to walk through these 3 steps of how we proceed with the high impact technology. So step 1 is identifying. How do we decide what to focus on? HIT prioritization is conducted each year based on quantitative foundational criteria developed through a transparent, collaborative, and consistent methodology designed to drive technologies through a step-by-step evaluation. In short, the DOE, the Department of Energy, is acting here as an objective resource to evaluate the vast, wide world of options that are out there and provide that information free of charge to the decision makers of America so that you all can decide where to focus your limited resources to be as efficient as possible while still maintaining productivity and overall allowing our society to flourish. DOE has no skin in the game. We hear this a lot from our partners that they're constantly being bombarded with phone calls from sales reps, and sales reps certainly are important, and they have a difficult job at times spreading the word of this new technology. We see our role here as being, again, that objective resource to promote just the ideas in general and let those decision makers then take it from there and decide what to purchase. So the HIT prioritization methodology helps prioritize technologies for deployment, focus, and also ensures open, consistent, two-way transfer of information and feedback. Selected technologies demonstrate large potential energy savings. They have potential for widespread adoption by industry stakeholders, and they need to benefit from involvement by the HIT Catalyst program. So information on hundreds of technologies is consolidated into the HIT matrix for screening and evaluation. We literally, I think the last list was certainly over 500, but 700 different energy conservation measures or energy efficiency measures, and they're put through several screens to be assessed. The initial screening here you can see is basically to assess for technology and logistics. It filters out technologies that are not applicable to the HIT Catalyst program. That's based on technical and energy savings factors. It might be a great invention. It just doesn't save enough energy nationally to be worth the focus. The technologies need to have high energy savings potential. They have to be relatively underutilized. So if a technology has great potential but it's already everywhere, there's no reason for us to focus on it. They also need to be ready for large-scale deployment in order to pass this first screen. The secondary screen. This is where we take market factors into account. So technologies are assigned a score according to 5 factors. That's stakeholder interest, criticality of DOE involvement, manufacturing capacity, cost effectiveness, and cost reduction potential. If a technology is lacking on any one of those 5, it's probably not going to be in that top 5 high impact technologies, which we have listed on the right there. A bit of a spoiler, if we go to the next slide, without further ado, here are the 5 high-impact technologies for last year and this year. LED troffers with controls, packages of building management information system, basically energy data management, shading, attachment, and awnings. Pretty simple technology there, but very important. Refrigeration controls and display case retrofits, primarily in grocery and cold storage settings, and then commercial fans and blowers. Anyone in a building right now is probably near a vent and feeling that air move. That air is moved by electricity and energy, and we want to find ways to save that. So as we evaluate these energy efficiency measures, we take them through over 20 criteria. We go beyond simple energy savings potential and also take a quantitative look at other factors like the market readiness level. I mentioned that. Will people actually buy this? Is it ready for prime time? The production capacity is another factor. Is there sufficient manufacturing out there to produce enough of technology X to actually make a difference nationally? And then finally, is there a role for government support here? If a technology is taking off on its own, should we allocate scarce resources, taxpayer dollars in this case, to promoting it? Probably not. So there are some cases where there's a perfectly good technology, but it's already moving, and it doesn't require an objective assessment from Department of Energy to support it. Peer workshops and responses to an annual request for information are incorporated into the HIT matrix to provide perspective on market factors. DOE seeks feedbacks from academics, federal agencies, utilities, regional energy efficiency organizations, technology providers, and building owners and operators. We want all comers to come and share their opinions on these technologies. The top scoring technologies are prioritized in this hit list, and we'll then move on to define the game plan phase, which we'll get to next. I have a few links peppered in here. There's also more resources at the end, but certainly this information is easy to find on the DOE website. You can use those links or do a basic Google search. On the next slide, I'm looking at basically how we define the game plan once we have these high-impact technologies selected. And in this case, basically what I'm doing is taking a look at the typical response. What is the objection that we're getting? I know people in the sales world deal with objections all the time. We do the same thing. And this is how we decide what to do next. So the cost is too high, we'll do a challenge. Ooh, I'd like to, but there's too many barriers. We can develop some resources. If there's uncertainty, we can do a demonstration. And if there needs to be some critical mass, we'll do an adoption campaign. So I'll go through those right now real quick. Next slide. If we identify high-impact technology and the general response we get is, yeah, that's good, but the cost is too high, Department of Energy can issue a challenge. So we'll implement this to overcome a communication failure in the market. When building owners desire a specific product that is not being provided by manufacturers or it's too expensive, DOE organizes building owners, identifies required specifications, and helps to challenge manufacturers to meet this demand. Bottom right there, we have an example of a rooftop unit. This is going back to 2010 when DOE issued the rooftop unit challenge to foster the production of more efficient rooftop units. And that was, by most accounts, a success. By 2014, 21 RTU models exceeded the criteria that we set out, and that was up from 0 only 4 years prior. So DOE verifies performance and recognizes winning manufacturers for these challenges. In that case, it was Carrier and Dakin. Next slide. Okay, second core activity to promote high-impact technologies, stimulating the market by providing resources. Pretty basic here. When the building owners say, there's too many barriers, uncertainties or unknowns, I don't get it, in short. What we can do is provide guidance on product selection. For key technical and energy performance issues, as buyers develop their purchasing criteria, we work with purchasers, tech providers, and other stakeholders to identify technology attributes that will enable product technical and energy performance. Tech specs are accompanied by a demonstration and case studies that support their value. So those specifications, which are available for at least 10 technologies, are listed on our website. We'll also provide high-impact technology application resources. Those help users operate their devices correctly. Next slide. The third core activity to promote high-impact technologies, which is the topic of this webinar, stimulate the market by providing performance with a demonstration. That is technical demonstrations. Real building demonstrations address the lack of objective performance and cost data that inhibit some technologies from finding their customer base. DOE helps identify, install, and monitor the performance of high-impact technologies in a real-world installation, and then communicate the results to the public via a case study. So this is kind of about addressing risk. Decision makers have limited availability of resources. They're concerned that if they allocate those resources wrongly, they might lose their job, they might be held up for public derision. So if the question is, does this technology really work, DOE will work with technology manufacturers, we'll find sites, we'll work with national labs to be that, again, objective third-party measurement and verification service to show that the technology really does work. We'll get case studies, we'll publish reports, we'll show that it's out there, it works, it can be bought. And we'll hear in a few minutes, we have two great examples of technology demonstrations in actions. One is a host site, the other is a technology manufacturer. So for those on the call listening, if you want to get involved, Better Buildings members are notified of these opportunities first. So please, just another plug to join Better Buildings. And also, again, that's a hot link there. You can sign up for a host demo site here, and that links to the High Impact Technology Hub, which is also listed later on. Next slide. Finally, the last activity we take on to promote high-impact technologies is to simulate the market with an adoption campaign. This is when the owners say, you know, I see that, for instance, LED lights are everywhere, but I think I'm going to wait. I think I'm going to wait and retrofit my parking lot once it's more common, maybe once the prices come down, once I can see that it's been done out there. Again, it's to some extent it's that risk aversion. Certainly an issue in any publicly funded operation. This adoption campaigns. This is the terminal hit activity. It incorporates many of the other resources developed via the program, such as specifications and case studies. The Department of Energy, through Better Buildings Alliance, works with industry partnership organizations, providing technical support to encourage their members to commit to installing a high-impact technology. I'm going to go through real quick here. Actually, I'm just about out of time, so I'm going to move through them. But the three campaigns we have going on right now are the interior lighting campaign, the LEAP campaign, which focuses on lighting in parking, and the Advanced Rooftop Unit campaign. In all those cases, I encourage people to join if you're doing a project related to interior lighting, parking lot lighting, or rooftop units. It's a pretty easy lift. What's in it for you? You have recognition. The goal of these campaigns is pretty much to stand and be counted. You can be recognized for showing leadership in energy efficient technology. You also have great opportunities for peer-to-peer learning and access to experts. So next slide is on interior lighting campaign. These slides are going to be made available later, so I encourage folks to take a look at those and read more about it. Definitely looking for projects related to troffer light replacement. Next up is Advanced Rooftop Unit campaign. This particularly is pertinent to retail locations. We partner with Retail Industry Leaders Association on this project. It's been very successful. And then finally, the LEAP campaign, Lighting Energy Efficiency in Parking, which is just coming to an end this year. Well, not coming to an end, I shouldn't say that. It's moving on from Department of Energy and going to be taken over by Green Parking Council to keep this information available, to keep the recognition going, and make those experts available for more learning. So with that, I'm going to go back to step 3, which is the tech demos, and talk specifically about 2 technologies that are progressing through the technology pipeline with real building demonstrations. Holly, I will send it back to you to move us along.
Thanks, Andy. Yeah, we are going to move into the nuts and bolts of some of these new technologies and their associated demonstration projects. Roberto, you're next up. Can you tell us a little bit about your experience thus far as a technology demonstration site hosting BuildingIQ's product at the Allen Hospital?
Yes, I can. Good afternoon, everyone. As stated before, my name is Roberto Nunez. I am the Site Director for Facilities Operation Engineering at the Allen Hospital / Spine Hospital. We are one of 6 campuses, not counting our regional hospital network. As previously mentioned also, is that I've been with NYP for over 12 years at various positions, and I've worked in controls for over 17 years. Because of my experience in controls, I know there are many opportunities for energy savings via the building management system. You can go skip 2 slides. The building management system energy savings opportunities are important to a variety of groups. Facility engineers, property managers, or organizations just looking for significant energy savings. Energy management can be achieved through the building management system in many ways, but most programs systems focus primarily on airflow reduction, as most of you are familiar with. Reducing airflow demand usually coincides with slowing down supply fan speeds, which reduces electrical consumption from your air handling units. The negative side of this process, unfortunately, is the possibility of affecting occupant comfort. And in addition, in critical care environments such as healthcare, if airflow or pressure is not properly controlled, infection control can be compromised and the occupants can be adversely affected. Next slide, please. Although the building management system offers many opportunities, its output capability is limited to the programming, data, and parameters provided by the installers and owners. Broad airflow and temperature set point ranges are used to provide adequate conditions for building occupants. Because of this, most systems do not respond efficiently to varying changes in the environment. I'm very sure most of you are aware of this as well. The BuildingIQ decision-making software serves as intelligence to the building management system. The intelligence enables the building management system to automatically update its set points according to sensible forecasts created by the software algorithms. For any of you who already have an existing building management system, you understand that even though you have preset parameters, you're constantly manually tweaking things or overriding things in order to get your required outcomes. The BuildingIQ software runs in conjunction with your building management system. The building management system continues as the backbone, while BuildingIQ actually runs in the background, continuing to analyze data from the weather and energy meters along with the building management system. Next slide, please. As you can see, these are many of the BuildingIQ interface points. BuildingIQ uses a diverse mix of interface points to provide data to their algorithms. determine the appropriate supply air temperature and static pressure set points. BuildingIQ measures and validates these data points for a specified period of time, creating a building profile, so better map your building points. Next slide, please. As you can see, the BuildingIQ software algorithms continually model, learn, and relearn the unique behaviors of the building. The data is communicated minute by minute to the cloud server for analysis, and subtle changes are made if needed to the supplier or static pressure set points. Engineers are watching daily and reporting results monthly for customer review. As you can see, it synthesizes the data. Software communicates sensible operational forecasts to the building management system, which the BMS automatically acts upon, resulting in net drop in system demand without sacrificing occupant comfort, which is a key factor. Next slide. As you can see, BuildingIQ calls this process the predictive energy optimization. Predictive energy optimization results in lower energy costs without sacrificing occupant comfort. Next slide. BuildingIQ basically refers to their service as an advanced artificial intelligence algorithms, which learns and models the thermal characteristics of your building. It continuously learns by analyzing weather, energy, building management system data coming from the building. It also intelligently determines optimal sequences, temperature set points, and other relevant system parameters. It automatically adapts to the changes in usage patterns, internal or external conditions. As you know, different attributes of the building changes the way your system responds, so you have to make constant changes. By having the system automatically adapt to it, makes you be more efficient and less headaches for all of you building managers. Next slide. As you can see, the BuildingIQ predictive analytics forecast future probabilities using current data and historical facts to better understand risk and opportunities where you're building. It extracts the data, determines patterns, and future outcomes and trends. Next slide. As you can see with the BuildingIQ, the predictive energy optimization dual benefits. The financial management tool, as you can see, reduces HVAC energy spend, creates cash in forms of savings. You can use the cash savings to finance other energy products, conserve the cash for the owners, avoid costs, and trim budgets, which is very important for all of us. Energy management tool, as you can see, reduces HVAC energy consumption, reduces demand, reduces greenhouse gases, analyzes HVAC performance, and dynamic energy usage, and continuous optimization. For all those who are currently involved with retrocommission, this is basically a continuous retrocommissioning tool for your building management system. Next slide. As you can see, this is just a profile of what you hope to expect from your system after implementing the BuildingIQ services. You have your average demand and the average savings you're seeing with the system is anywhere from 10 to 20% conservatively. Next slide. So this is actual data that we have collected from the Allen Hospital. Basically, it's just showing you a profile of one of the air handler units and all the information that it's collecting. Utilizing this information is how the algorithms implements the adjustments, so make sure that your system's operating at the most optimal parameters possible. And the process also, using the exact data, it takes all the information and updates it to their cloud server. That's why it's an ongoing monitoring service. Next slide. As you can see with this profile, by utilizing the BuildingIQ service, you're minimizing or avoid drift outside your temperature control limits, which was the key aspect behind the service and what we all want to accomplish. Next slide. As the power profile shows you, for optimized temperature control looks much different. Noted that the shaded green areas, periods of HVAC energy savings during our drift periods. For the extra shot of cooling, we can see an increase in energy use, but the net total for the day, is an overall savings in energy. Next slide. This is an existing case study that was completed by BuildingIQ in which they were able to achieve a 17% reduction in HVAC spend. We are conservatively predicting 10 to 20% energy savings at the Allen Hospital. This would translate just for our campus alone anywhere from $220,000 to $440,000 in savings per year. Once we implement this out throughout the organization, this would translate to millions of dollars in energy savings per year for us. That's how much an opportunity this is for us. Next slide. This BuildingIQ portal building visualization is basically a profile of the data information they can provide to you once you implement this service. Next slide. As you can see, these are the many customers they currently have on their list, and we're one of the many high-profile names they have. Next slide. And just in summary, I just want to state that combining the advanced machine data and analytics and predictive modeling to deliver intelligent automated optimization of HVAC maintaining comfort. This is, as you can see, a proven 10 to 25% HVAC energy savings and up to 20% peak load reductions during demand response, which I didn't really cover, but is a great opportunity. And as you can see, it's also backed by industry-leading vendors that partnered with U.S. and Australian national labs. And I see as my time's running up, I can close out, and I'll pass it on to the next presenter.
Okay, thanks very much. Appreciate it, Roberto. Sounds like great initial interaction with BuildingIQ and getting the technology going at NYP. So thank you very much for both participating in this demo, and I should mention that New York Presbyterian Hospital is also a Better Buildings Challenge partner, so they've been a partner for quite some time, and actually that's how this demo came to fruition, is that we do typically publicize our technology demonstration opportunities with our Better Buildings partners first in the Alliance and the Challenge. So thank you very much. And I'd like to remind our audience that we are collecting questions through that chat box on your webinar screen. We will have time for a Q&A period at the end of the session. So please go ahead and send those in. And I'd like to move next to Udi at enVerid. Udi, can you tell us about enVerid, how these intelligent scrubbers work, and a little bit more about the associated energy reductions that we're seeing in demonstration sites?
Yeah, gladly so, and thank you, Holly, very much for including us in this webinar, and for all the audience for taking your time to listen to what we have to say. Let's jump one more slide forward, please. So this will come as no surprise to everybody, but buildings use a lot of energy specifically for the purpose of managing indoor air quality. And the way that comes to bear is that we constantly bring in outside air into the building and reject the air that's inside the building through exhaust. That is done for a very specific purpose, which is to remove from the building what's called molecular contaminants. So unlike dust particles and germs that can be dealt with directly, molecular contaminants, which is carbon dioxide, formaldehyde, and other VOCs, the only way buildings know how to deal with them is essentially by replacing the indoor air with air from the outside. And that's essentially universal practice, which is in every commercial building. But it costs a lot of energy, and the main reason it costs energy is because you're bringing outside air, which is always at the wrong temperature. It's either too cold in winter or too hot and humid in the summer. In both cases, we're substantially increasing the energy load on the HVAC systems through this process of outside air. Let's jump to the next slide. So the idea behind enVerid's offering is very simple. Let's not do that. Let's not throw all this air outside. Let's keep it indoors, clean it, and recycle it. Essentially, if we had a technology that could efficiently remove these molecular contaminants, then we wouldn't have to throw out this air and bring in these large amounts of outside air into the building, and we would benefit with the lower energy costs, lower loads on the HVAC systems, and quite often end up with even better indoor air quality. So that's the whole big idea, and that's what brought to us the concept of the HLR, which is the next slide. So we call it HLR, which stands for HVAC load reduction. It's essentially a network of smart indoor air scrubbers that we can install in the building. It can be installed as a retrofit. You have a picture of one of those units here on the slide. But let me focus a little bit on the cartoon here on the left side and explain how this works. The unit essentially does not get in line with the main airflow, but you put it side by side next to your HVAC air handlers, or in fact you can put it in the return air plenum. It sucks in air from the return air line or the plenum. Inside the unit, the air comes into contact with a specialized blend of novel sorbent materials. These materials, which were invented and developed in the process of making this technology real, are designed to capture all the range of indoor air molecular contaminants so that the air, after it passes through the HLR, comes out clean. And it's basically reintroduced back into circulation. Now, the unit needs to be cleaned because as it accumulates these molecular contaminants, eventually it gets saturated. So a couple of times a day, it goes through a self-cleaning process where it essentially closes itself off from indoor circulation, it takes warm air, which is brought from outside the building, and flushes the sorbent materials. And after doing that for about half an hour, the sorbent material is clean, the contaminants are exhausted outside the building, and the unit is ready to start another cycle. And you can do this in a periodic fashion indefinitely. It can go like this for months and years. So, and while it does this, it also handles the reduction of the outside air inlet by taking control over the electromechanical damper that manages the outside air inlet into the HU. So you get the combined function of cleaning the indoor air and reducing the outside air introduction to the building. And all of this is managed by very sophisticated software that sits on servers and communicates in a wireless fashion with all these units that are installed in the building. Let's move on to the next slide. So the idea is simple. The technology is fairly sophisticated in terms of material science, electronics, and mechanical. But it raised the question, why is it now? Why do we have this technology now and not maybe 10 or 20 years ago? And it's kind of interesting. There's a convergence here of multiple things that have come together to make it now the time for deploying a technology like this in commercial buildings. The fundamental concepts of cleaning indoor air from these molecular contaminants evolved in the development of manned space travel, like space stations and the space shuttle, where there is no opportunity to bring in fresh outside air into the unit. And these concepts were initially developed there. In addition, there's been tremendous progress in the last 20 years on sorbents, especially sorbents for capturing carbon dioxide, because carbon dioxide has been a contaminant of outside air, and the increase in CO2 levels has led to a tremendous amount of investment and research in better ways to capture carbon dioxide from air, which has indirectly benefited the development of this indoor air treatment technology. And finally, there's been evolution of the regulatory landscape, and ASHRAE in the last decade has introduced alternative paths to managing indoor air quality that allow for the building owner to, instead of replacing the outside air at a fixed amount, manage indoor air quality to air quality targets without necessarily having to bring those amounts of air into the building. So it's the collection of these three factors that have brought about today what we call the HLR technology that we are now offering to buildings around the country. Let's get to the next slide. So let's talk a little bit about the benefits. The unit can be retrofitted in essentially in any building. You can put it on the roof. If you have rooftop units, you can put it in a mechanical room, in a plenum. Typically, what you find is about 20% reduction in the energy usage of the HVAC systems worldwide, year-long. The impact is much larger during the peak season, especially in the heat of summer. You can see impacts of 40%, and we've seen even 50% reduction in the power load on the chillers in hot climates. When you aggregate over the course of the year, you see a retrofit payback of about 1.5, 2 years, sometimes 3 years. When you talk about new construction, the benefit is even greater in the sense that you can reduce the overall size of your chiller plants and your other infrastructure because the peak load is reduced, and typically your systems are sized for peak load. Other benefits include also improvement in indoor air quality, especially when the outside air is not very good. That's when bringing less outside air into the building actually benefits you with improved indoor air quality and longer lifetime for the HVAC filters that don't have to deal with so much outside air. Next slide, please. So Here's a case study, a recent installation we've done in Miami, in the University of Miami Wellness Center. And one of the interesting things about this technology is it's very easy to demonstrate its benefit, because once we have it installed, we can turn it on for a week and then turn it off for a week, or in fact, day by day, and do direct comparison both of the energy consumption and the measured air quality in the building in the on days and the off days. So it gives us a very clean, isolated signal of what the benefit is. And what you're seeing here is the green bars show the performance when the unit is on, and the blue bars when the unit is off. And you can see about 29% improvement in the energy consumption, and significant improvements actually in all measures of air quality, despite the fact that we're bringing in a lot less fresh air into the building. So, and this demonstration has just started this last summer. We'll keep doing it now for the next year, year and a half, and it's sponsored by the DOE, the HIT program, which we're very appreciative of. Let's just jump to the last slide because my time is running out. I just want to point out we're now getting recognized by many organizations that care about these things. ASHRAE has officially recognized that this approach to air quality is legitimate and sanctioned. The Green Building Council is giving LEED points. One of our customers got 9 LEED points for deploying our technology. The GSA has a demonstration running right now. We're working closely with Johnson Controls, and we even got the 2015 Frost Sullivan Award for the best practice in HVAC, the most innovative company in the HVAC arena. So that's my story today, and thank you again for your attention, and I'm happy to take more questions.
Thank you, Udi. Great explanation of what's going on inside this box, and explanation of what is a pretty complex product functioning in our demonstration buildings. Thanks to all of our audience members who are sending in questions. They're just rolling in here, and we're going to get these to as many of our panelists as we can. Before we do that, I'd like to move to the next slide, please. And I think we'll move to the next slide on this one. Thanks. Okay. There we go. So this is the link at the very top here. This is a little bit more information from each of our 3 panelists. The link at the top from U.S. Department of Energy is the High Impact Technology Hub that was mentioned by Andy. So if you are interested in demoing technologies with us, check out the hub. That's where we are always listing demonstration opportunities with our HIT Catalyst program. We also list those on the Better Buildings newsletters that come out to our partners. So if you are a Better Buildings Alliance member or Challenge member, be sure to check out the Better Buildings Bulletin for those tech demonstration opportunities. If you're not yet involved with Better Buildings, get involved with us so you can follow that as well. A couple of items from New York Presbyterian Hospital. I mentioned that NYP is a Better Buildings Challenge member, so just wanted to highlight a case study that they have already done with us, their Gallery Walks implementation model, talking about their strategies from an organizational perspective for how they are getting to the 20% portfolio-wide building energy savings that they have committed to through the challenge. So, today we're talking about BuildingIQ as one of the technical strategies that they are using to get there. But the Gallery Walks case study talks about organizational strategies and how they're really engaging their own staff to be a part of the energy savings opportunities and to submit and look for energy savings opportunities in their daily jobs. And then finally, a link from enVerid with more information about the technology. We've had a number of questions about how the systems work, and we'll try to get to as many of those as we can, but check out this specific link for more detail on the enVerid technology. Okay, so let's go ahead to the Q&A portion of our conversation. here. Where should we begin? Roberta, we have a question for you just on the relationship between the host site and the technology company. So wondering what interaction your facilities team has had with BuildingIQ and getting started on the tech demonstration and you know, throughout the demonstration period. And also question about fees associated with the software, and if it's an ongoing sort of subscription or if it's something that a box that you purchase and use. So can you take that one for us?
Not a problem. So yes, so basically I've been working hand in hand with BuildingIQ implementing the software. Working at a healthcare facility, we work with very tight secured IT network, so getting them access and setting it up. So it's been a little more difficult than some other areas because of our IT process, but we've been working hand in hand. BuildingIQ is basically a service. So basically what you do, you're paying for an ongoing service because it's 24/7 operations, and they're constantly monitoring your system to make tweaks and changes to make sure you're running optimally. So the service calculation is based on how much it's basically you're expecting to have a certain amount of savings, so it usually comes out to a percentage of that. So yeah, so
great. And
go ahead.
Yeah, no, we had a follow-on question, well, a couple of follow-on questions, wondering if the BuildingIQ service can be adapted to communicate with energy storage software or to identify peak loads.
So to my knowledge,
react to that.
Yeah, so to my knowledge, we already have a existing curtailment service. But one of the things, once BuildingIQ is fully implemented and once they have a full building profile, they can actually act as a peak demand system, and I believe they can work with existing software as well. Unfortunately, I know what they've done for me, and I'm briefly knowledgeable of some of the other services they have, but to my knowledge, I believe it does work with other systems since we have one already in place as well.
Great, and a point of clarification on your HVAC equipment. So you took BuildingIQ and added it to your existing HVAC equipment, right? You didn't put in new equipment before or in conjunction with this.
That is correct. So it's basically all my existing equipment, existing building HVAC equipment, existing building management system. BuildingIQ basically puts a small device head in to collect the data, and depending on the type of implementation, you might have a couple additional meters installed. But other than that, that's it. No additional HVAC equipment is installed in order for their service to be implemented.
Okay. My guess is that you don't know the answer to this question, but we have an audience member wondering if BuildingIQ has been deployed in Hawaii or other Caribbean countries, that sort of climate. Do you happen to know that?
I don't know specifically about Caribbean countries, but I do know they're international. So I would tend to fail on the answer yes, but I don't know specifically of any Caribbean countries they're working in now.
Okay. Great, and I'm going to turn to Udi for just a second with some questions about the specifics of the HLR. We have an audience member wondering how the molecular contaminant removal of the efficiency of the HLR is determined, and over time, if the sorbents are used up, and how you know when the efficiency is degraded. I would assume that if you're testing the contaminants in the air and you start to see a rise in that, then you know something needs to be replaced.
Well, yeah. So there's three pieces here. One of them is the monitoring of the air quality. We have built-in sensors, not one but multiple sensors in different points in the HLR. At the input and the output of the HLR. So we are not only monitoring the building indoor air parameters at all times, and by the way, these are specialized sensors that we've developed for the HLR. They address VOCs and CO2, as well, of course, as temperature and humidity. But we also look at the input and the output and compare the two. And I think the audience person is alluding to that. So by comparing the input and the output of the HLR, we can tell what efficiency the sorbents still have in them in terms of the removal. So if you're coming in with a certain amount of a contaminant and the output you have a 90% reduction, that's pretty good. If there's only 10% reduction, that's an indicator that the sorbent is approaching its saturation point. And that's one of the inputs that the unit software takes in to decide when to run a regeneration cycle, which was what I was explaining before, when we close off the circulation from the building into the HLR, heat up the HLR, and flush it, and that kind of regenerates the sorbent materials. And this happens typically a few times a day. The sorbents reach saturation, typically it's carbon dioxide saturation, a few times a day, and we run this regeneration. But like I said, the sensors here are a very important part of the technology. One last comment, over months, there is a slow degradation in the potency of the sorbents. And for that reason, once a year, we replace the sorbents in the unit. So once a year, it's like replacing filters in an air handler. We come in, the sorbents are based in these cartridges that look a little bit like filters. We pull them out, put in new ones, and that is the annual maintenance cycle for the HLR.
Okay, that's really helpful. We had a couple of questions about maintenance and, what needs to be replaced when, if ever. Okay. Also had a question regarding retrofit versus new construction, if this is an equally effective solution for new construction versus retro.
It's definitely effective for both of them. The fundamental air balance and the air quality issues are not really different. It's always easier in new construction because if you design it in, it leaves less guesswork in terms of where to put the units and how to connect it and make sure that you have the electric power right next to where you want the unit. If you're doing a retrofit, you have to go in and figure out where exactly in the mechanical room it's going to fit, and you got to bring an electrician to pull wire. So it's a slightly bigger undertaking to do a retrofit in that regard, but frankly, it's not that hard. I mean, this is a plug-and-play unit. You bring it in, you power it up, and it's ready to go. We like to call it a plug-and-play system. So it will work equally well in both. The only other thing I would say is that in new construction, in principle, if you design the building with the HLRs, you can actually reduce the tonnage of your chillers. And that can be a small or a very large benefit depending on the situation. In buildings where there's, for example, ground loop heat pumps, we've had one customer where the capital savings because of the peak reduction was enormous. That by itself more than paid for the installation of the HLRs.
And kind of similar question that we had for BuildingIQ, is there a climate zone where this looks like it's working better or worse than other places, or is this solution pretty much climate agnostic, if you will? Sorry, that was for Udi.
Oh, I'm sorry. I thought that was for BuildingIQ. Oh, so let me. Is that for me, the question?
That's for you, yeah.
Okay. Well, it works in all climates. The first generation systems that we had worked only in air conditioning, basically in summer or in cooling mode. The new generation systems that we just have come out with, they operate both winter and summer, so they will save heating energy in the winter and cooling energy in the summer. The energy savings is larger the more extreme the climate is, so we find the best, I would say the shortest payback typically will come either when you're in areas with very long hot summers or very deep and long winters. And if you have kind of a mild climate, the payback is longer simply because there's less energy to be saved. But the system will operate essentially in any climate.
Great. We have, I can tell, a few lead specialists on the line interested in if and how the system helps to meet ASHRAE 62.1 indoor air requirements.
So ASHRAE 62.1 IAQP allows buildings to manage indoor air quality without necessarily a prescribed amount of outside air. So as long as you monitor what's called the contaminants of concern. And I will say this, it's a fairly complex topic. So I cannot really address it in depth right now, but we have engaged deeply with both ASHRAE and with the U.S. Green Building Council, with a lot of experts on the topic. The news is very good. I mean, everything is extremely compatible and compliant with the code. Part of our service as we install these as retrofits is to make sure all the I's are dotted and T's are crossed in terms of meeting the requirements of the ASHRAE IAQP. And it's not super hard once you've done it a few times and you know how to do it, but for building owners who've never done it before, it is a little bit of an intimidating process. So part of what we do is we really make that, we take the pain out of that, if you will. One final comment I will say is that the IAQP, the ASHRAE's IAQP is evolving, and I've just learned last week that there's going to be additional discussions in this coming AHR meeting where they will look for further ways to simplify the IQ procedure so that it is more broadly adopted. And we're on top of those things all the time.
Great, thank you. And we had one final question about residential applications, if you've used this at all in residential or primarily commercial.
So, you know, in most, the vast majority of residential applications, there is not a intentional or controlled inlet of outside air into the house or the apartment. So there's really not an opportunity to reduce the outside air intake and thereby save energy. So as an energy savings device for residential markets in the United States, it's not really currently on the agenda. What we are seeing, though, is there are many residential applications where there's an air quality issue. Frankly, more outside the U.S. than in the U.S., but in these markets where there is an air quality challenge, the value of this technology is as an air quality improvement device, and we see tremendous demand for that in some key markets.
Great. Thanks very much, Udi. One question for you, Andy, probably our parting question for our audience is, what, if any, technology demonstration opportunities are there right now, and what do you anticipate coming down the pike?
Okay, great question. You can find that information on the links that we provided on the High Impact Technology Hub. There's a section called Host a Site. And if you click through to there, you'll see there's 3 technology areas that we're focused on right now, and we're looking for buildings with specific characteristics relating to those. So for a modular HVAC load reduction with smart scrubbers, if that sounds familiar, Udi, we're looking for office. We're looking for office, education, retail spaces, airport terminals, things like that, that would benefit from that technology. We also have a tech demo forthcoming focused on air barriers and sprayable liquid flashing. That would be new construction, and then alternative and low global warming potential refrigerants. That would be grocery, supermarkets, warehouses with refrigeration systems. And again, all those are available on our website. In terms of what is coming down the pipe, we will have more focus on energy management systems in general. We will have we have a project going in the Northeast that is focused on lighting controls, so things like motion detectors, daylight sensors, daylight harvesting, things like that. So definitely this is a dynamic and changing site, the High Impact Technology Hub, so I encourage people to keep in touch with us, keep an eye on the site. Again, join Better Buildings to be kept up to speed on what's going on, and we look forward to many more technology demonstrations in the future. I think that covers it.
Yes, and thank you, Andy. And Kendall, can you run back to our Accelerate Performance slide? I want to get this in here right now. This is an initiative funded through Department of Energy in conjunction with Seventh Wave, looking for participants for a new construction initiative. So if you are interested in, particularly if you're looking at zero energy buildings and working on or designing a zero energy building and might be interested in technical assistance and perhaps financial incentives to help you work through a construction and procurement process that we think can be beneficial to zero energy buildings, please touch base with Seventh Wave. The website is listed down there on the bottom. Seventh Wave is both a Better Buildings Alliance affiliate as well as a FOA funding opportunity awardee. And we'd love to get folks involved who might be in pre-design with a new building and could take advantage of this opportunity. So with that, let's head to the very end. Kendall, I just want to give you a heads up for our next webinar, which will be Tuesday, February the 2nd from 3 to 4 p.m. We'll be focused on water efficiency and how that can drive energy savings. We have a nice broad spectrum of presenters. United Technologies Corporation, UTC, will be presenting from the industrial side. The City of Atlanta will be talking about their water reduction efforts in the city's infrastructure. And then also Better Buildings Challenge partner Intercontinental Hotels Group, IHG, will be talking about their worldwide efforts to reduce water in their hotels and also working with their franchisees. So please register for that. We hope you can join us for the February webinar. And with that, I'd really like to thank our 3 panelists today very much for taking time to be with us and talk to us about your technologies and your programs. Feel free, let's move on to the next slide where you'll have contact information. Oh, goodness. There we go. Contact information for our panelists. If you have specific questions or you're interested to demo the enVerid system in your building, please feel free to reach out to our panelists with any additional questions. And let's go back one slide to the Better Buildings Summit. We, of course, want to put in a plug for our upcoming summit, which is May 9th through the 11th here in Washington, D.C. Registration is now open for that event, and you will be hearing more about these technologies at the summit. We'll have a really wonderful slate of panels and presentations and events for you. So we hope you can join us there. Of course, as always, keep up to date on all of the happenings in the Better Buildings Initiative by following us on Twitter and signing up for the Better Buildings Bulletin, our newsletter that comes out once a month. You will receive an email notice when the archive of this session is available online. And thank you very much for taking time to join us today. Take care, everybody. Bye-bye.